PU, a name of a club of sorts at Los Alamos Bomb Factory, a rather strange name for a club, don't you think? Why would anybody call themselves this name? It's rather childish actually. Well, the name is an ironic pun that mocked 4 people making up a group of friends that somehow, through some kind of accident, got plutonium into their system and ultimately their urine. Hence UP as in your urine and PU as in plutonium. The first of the 4 was Marble, who decided to poke a hole into the gloves of a glove box to see what would happen if he exposed himself to some plutonium and its radioactivity. When he reached through and took his arms out, you were able to notice a tiny little black spot on his finger where the hole was located on the gloves. And just from this little amount of exposure, plutonium could be detected in his system for 50 years to come. Why is this so important, you may ask? Well, plutonium is very dangerous, as you will learn in this video. Furthermore, plutonium is used in nuclear bombs, the very same bomb that bombed Nagasaki. Got your attention now, huh? So before we can go any further, we must take a step back. Going back to as late as December of 1940 to January of 1941, plutonium would be artificially discovered and created by Glenn Seaborg, Arthur Wall, Edwin McLean, and Joseph Kennedy at the University of California, Berkeley, where once the discovery was reported, it was taken in by the Manhattan Project and kept a secret, and we all know how that played out. But what was worse than the actual explosion was the radiation emitted thanks to the plutonium that caused a widespread of deadly diseases, including cancer, throughout a radius much bigger than the blast zone that caused cancer in most, if not all, the survivors of the explosion, wiping out 96% of the survivors, showing how the radiation emitted by plutonium alone can be dangerous. In order to know what exactly is going on, we're going to have to go to the subatomic scale. Firstly, plutonium is made out of protons and neutrons in the nucleus and electrons in its energy shells, just like any other atom. And the number of electrons per shell go as follows: 2, 8, 18, 32, 24, 8, and 2. But what plutonium has that most other elements don't is an unstable nuclei. And these unstable nuclei cause it to be radioactive by naturally being able to release energy in the process of shedding high-speed energy particles. But its goal is not to be unstable and radioactive, but instead it's just trying to become more stable and shed more of those high-speed charged particles, which is quite sad if you think about it. Furthermore, plutonium contains alpha radiation, which is much more dangerous and less common than beta radiation. Alpha radiation is a highly ionizing form of radiation. External exposure to alpha particles isn't very harmful due to having a low penetration of depth that can be stopped by your skin. On the other hand, when inhaled, alpha emitters can get inside cells and be extremely hazardous. Once inside, the alpha rays can cause between 10 to 1,000 more chromosomal damage than both beta and gamma rays. And according to the Environmental Protection Agency, usually plutonium gets into the body via your lungs, then it spreads throughout your body, bones, liver, and other organs throughout your bloodstream, thus causing a bombardment of alpha radiation to organs and tissue and greatly increasing the risk of cancer, especially in your lungs, liver, and bones. Plutonium, also known as element 94, can be located in the actinium group in the periodic table. The average plutonium isotope contains 94 electrons and protons with 2 valence electrons, and it has a whopping 150 neutrons. It's a solid at room temperature. Its density is 19.816 grams per centimeter cubed. Its melting point is 640 degrees Celsius or 1183 degrees Fahrenheit. And its boiling point is 3,228 degrees Celsius or 5,842 degrees Fahrenheit. It is a highly unstable and highly reactive element that is extremely dangerous in all of its states of matter. Such a dangerous element can't be natural. Well, yes and no. Plutonium once existed naturally, but its short half-life caused us to evolve with no tolerance to it, making it even more dangerous to us than uranium. We've established that plutonium is used in devastating bombs, but what about a more peaceful approach on how we can use plutonium? The first thing that would come to my mind in this scenario would probably be the fact that plutonium can be used to provide fuel and energy to spaceships and space probes. And this is all thanks to the fission chain reaction that plutonium can undergo. Although an efficient source of energy, this can prove to be harmful, and because of its harmfulness, space probes only use this form of energy when it's too far away from the sun to use its solar energy. The second would be the use of plutonium in our nuclear power plants to create energy for ordinary citizens. And again, this is all thanks to the fission chain reactions. So what exactly is a fission chain reaction? Well, this reaction refers to a process in which neutrons released in fission produce additional fission in at least one other nucleus. This nucleus in turn produces neutrons and the process repeats. And this process can be controlled to form nuclear power or uncontrolled to create nuclear weapons. If we were going to talk about compounds, there really wouldn't be any commercial application, because again, this is due to the fact that plutonium is one of the most toxic and dangerous elements known to man. In fact, scientists don't even directly interact with plutonium. Instead, they use remote-controlled devices and stand behind a special shielding to protect themselves from the radiation produced from plutonium. Physically, under standard conditions, plutonium is a hard, brittle, silvery, shiny metal. It's a poor conductor of electricity and heat, and when it's exposed to air, it becomes highly covered in a dark gray layer of oxidation. Plutonium is very warm to the touch, to the point where when placed underwater, the water can begin to boil. It has an unusually low melting point as well as an unusually high boiling point when compared to similar elements. Plutonium can form alloys and intermediate compounds with most other metals, in which some can have superconductive abilities that allow the production of nuclear fuel pellets. But again, there's really no compound that includes plutonium that can be used, commercially that is. Whew! That was a big headache for both me and you. Well, thank you for tuning in, and please consider subscribing. Adam, signing out. Wait a second, hold up. Plutonium does occur naturally. It's just that plutonium is created in very small, finite amounts in the Earth's crust, and it's formed through ores of uranium. And when the uranium breaks down, it forms into plutonium. And a fun fact, actually, when plutonium breaks down, it can also form uranium. Just a thing to keep in the back of your head. Adam, shutting off.